Hi, everyone. Thanks for joining today. In this talk, I'll talk about building a real-time user-facing dashboard with Airbyte, Redpanda, and Apache Pinot. Let's dive right in. I'm Dunith Dhanushka, a senior developer advocate from Redpanda. So if you are not heard of Redpanda before, it's a streaming data platform quite similar to Apache Kafka in functionality. Also, it is fully compatible with Kafka APIs, but offers a far more great performance and simplified operations compared to Apache Kafka. So let's focus on a hypothetical use case to start our talk. Let's imagine we have a SaaS platform that allows its users to track their daily spending, right? As a user, you would register with this platform and start tracking your expenses, right? For food, groceries, utilities, etc. So as of now, it has a website and a mobile app, and they also write to the same MySQL database as the data storage system. So far, so good. And then the product management team comes up with a new feature to build an analytics dashboard to visualize the daily spending. Because as a user, you would love to see a detailed breakdown of your spending in a pie chart rather than reading that on a table, right? So if you happen to be the lead engineer or the lead architect of this feature, how would you design and build and ship this feature to the production? So let's try a couple of options. Let's start with a simplest solution possible first. So in here, why don't we directly serve analytics from the MySQL database, which happen to be our operational database as well, because things are very easier, right? So in that case, you can have a Streamlit dashboard to build the analytics visualization. For those who are not familiar with Streamlit, it's a Python-based data-driven framework. So you can write Python code to fetch data from MySQL and add your logic to do the visualizations and expose it to the end user base. Simple, right? So let's see why it's not going to scale in the long term. So there will be two problems, the throughput and the latency, because we are going to expose this dashboard to the entire user base, and we are not going to restrict it to internal BI or handful of data scientists. The user, this dashboard will be accessed by many users online concurrently. Suppose we have a 1 million growth in 1 year, and at some point, these 1 million users will try to load the dashboard at the same time. That will result in having a bottleneck on the MySQL. Also, the latency will be a problem as well, because the type of queries we are using to populate the dashboard is typically OLAP queries with heavy aggregations and filtering on the end. So once the data volume grows, these queries tend to take more time, so will result in a sluggish performance at the dashboard. So what could we do to mitigate these problems? So another solution would be to pre-aggregate these analytics using an ETL solution and write the computed metrics to the data warehouse so that we can eliminate the time takes to run ad hoc or on-demand aggregations. So in this case, we have an ETL pipeline to periodically extract data from MySQL, process it with Apache Spark, and write it down to data warehouse. This seems like a far better option than the first option, but there are still problems in terms of throughput, latency, and the freshness of data. Because we are serving analytics directly from data warehouse, it is not fine-tuned or optimized for user-facing analytics scenarios. Usually their throughput and latency is limited. Also, we will have a problem with the data freshness, as the data will take some time to go through the ETL pipeline and finally show up in the dashboard. So to address this throughput, scalability, latency, and data freshness issues, we'll consider a third solution, which happened to be our ultimate solution. The solution you see here has two significant features. It is first, it's real time. That means whenever something changes in the MySQL, the resulting Streamlit dashboard will immediately change, gets updated in real time. Also, the solution is capable of delivering ultra low latency query results even at higher query throughputs. So there are three new components we see here: Airbyte, Redpanda, and Apache Pinot. Let's have a detailed look at each of them. So first, we have Airbyte. So why Airbyte and what is Airbyte? So as you already know, Airbyte is an ELT tool. So the purpose of Airbyte here is to extract the change data from the MySQL source database as they happen. In order to do that, we utilize the CDC, or the change data mechanism, in the Airbyte engine. So underneath, it will utilize this DBCM framework to do that. And then we'll use a sink, Kafka sink, to deliver these results. So whenever something happens in changes in the MySQL database, Airbyte can pick up this change. It can transform into a nice event, and it can deliver it to a Kafka sink, or whatever the destination of choice. We use Kafka sink here because we can easily swap it out with Redpanda, because as I said earlier, Redpanda is API compatible with Kafka as well. And then once we have these change data streams coming in, we need some sort of a buffering mechanism to ingest them scalably and store them durable manner until it is consumed by the downstream component. So that is why we need Redpanda here. And then finally, we have Apache Pinot, which is a real-time OLAP database, also a streaming database as well. That means Apache Pinot can be configured to consume data from Kafka. So we can also configure Pinot to ingest from Redpanda here as well. So once data comes in, Pinot can convert them and make it available for querying within a matter of seconds. So that means the change data will immediately visible in Pinot in a matter of seconds. And then this can be served to the analytics dashboard within almost immediately. So that's the beautiful thing. So we can preserve the data freshness. Also, Pinot has been designed from the ground up to support ultra low query latencies, which usually falls in sub-second range, millisecond range, and even at high query throughputs. All right, let's try to recap what we have discussed so far. So there are three things we need to mention here. First thing, this incremental CDC mechanism of Airbyte allow us to extract source database changes as they happen in real time and stream them to a destination of your choice. Here we choose Redpanda because we need to decouple the Airbyte engine and Apache Pinot for scalable and durable ingestion. And then we can use Apache Pinot as the query, this serving layer here. So we can serve analytics queries on demand in a scalable and low latency manner. All right, with this solution, we can finally, this solution can be scaled to millions and billions of concurrent users in an easy manner. So that's the goal of this presentation. I hope you enjoyed the presentation, and thanks for joining. If you have any problems or questions, feel free to reach out to me on Twitter, Medium, or LinkedIn. Thank you so much.